Hi everyone. We're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers n. Again, these are more advanced, and I assume that you know some things already, and you're not starting with the hard ones first. So basically, we're going to check for n equals 1, and that means we're going to plug 1 into the sum, and that should equal your 1 times 2, which is 2. This is your first term here. So basically, I'm going to do 1/3 times 1. 1 plus 1 is 2, and 1 plus 2 is 3. This is 1/3 of 6, which equals 2, which equals our 1 times 2, which is 2. All right, now we're going to say if it works for some k, and I'm going to copy this down again. I'm just copying down again this first line. Alright, so I just copied that down. If it works for some k, then it should work for the next term, which would be k plus 1. So I'm going to copy this statement down again. 1 times 2 plus 3 times 4 plus 5 times 6 plus dot 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 plus k times k plus 1. Now the next term is going to be, you take this term, and so for k, we're going to put k plus, it doesn't equal, it's plus. So it's going to be plus, the next term will be k plus 1 times k plus 2. Alright? And then on the right side, we have 1/3 k plus 1 times k plus 2 times k plus 3. So I'm just adding 1. I'm adding 1 to all of these and getting my next term. So basically we want to fix this left side and make it look like this right over here. So I'm going to take care of the left side now, and I know that this bit equals this. So I'm going to substitute and write that down. 1/3 k times k plus 1 times k plus 2. Then I'm going to add my next term, which is right here, plus k plus 1 times k plus 2. Now if you notice this is like in two separate sections here. And I notice that I have a k plus 1 in both of these. So I'm going to pull that out as your highest common factor, and then write my 1/3 k times k plus 2. Then, so that goes together, plus your k plus 2 here. Right? Now, in order for this guy, we want it to look like this over here. So in order for this to belong to this quantity in here, I'm going to multiply them by 3 because of this 1/3. So I'm going to have k plus 1, and then I'm going to have 1/3 k times k plus 2 plus 3 times k plus 2. Now this whole part goes together, and I can pull out my 1/3 in front, which is what we want here. So I'll pull out the 1/3. I have k plus 1, and then I'm going to simplify this part. So that's going to be k squared plus 2k plus 3k plus 6, and this equals 5k. So factoring more, so I'll squeeze it in. You have 1/3 k plus 1 times k squared plus 5k plus 6. And when you factor this, you're going to get those two factors. So my answer is going to be 1/3 k plus 1 times k plus 2 times k plus 3. This is just from factoring. So, which is what had to be proven. The left side looks like the right side. Condition 1 and condition 2 have been satisfied. Therefore, this given statement is true for all natural numbers n. Thank you and have a nice day. Bye-bye.